So what I wanted to talk about was start with the problems we're trying to solve. When you think about scaling, and the sort of central lesson of this stuff is the 80-20 rule, right? So you can do 80% of your idea in 20% of the time, and then the last 20% of your idea, which is like, oh, I want to scale this, actually turns out to take 80% of the time. So like polishing and making your thing actually run, if you want to be able to have more than just a research group use it, it takes a crap load time, way more time than just getting your idea to the point where you can talk to somebody about it. And we leverage that as a strength in the Media Lab, right? We say, oh, okay, I'm going to do that 20% of the work just so I can get you to understand the idea enough that we can have a conversation about it, right? The thing I'm building is actually a thing to think with, not the actual thing I want. I want it to provoke a conversation of what the future might be or what certain possibilities are so that we can actually get to that place. But I don't need to build the whole thing most of the time. That's generally what the Media Lab's approach is that if we do that sliver of the work, then we don't need to spend 80% of the time doing the rest of it to make it function. So we can very quickly iterate because we might be having the wrong conversation, right? So this class is about when that's not the case, when you actually want to be able to build something that people are using. And making those decisions is very difficult, right? Like if you're doing a research study and you have 10 subjects, then you're good. If you have 100 subjects, then suddenly you get very popular and you're in Wired and you have 10,000 people hitting it at the same time. You're like, oh crap, this is really good and really bad. So these are the main questions you need to think about, right? So replication, you want to make sure that it's easy to get multiple copies of whatever piece of your architecture, right? And again, I'm not going to talk so much about hardware because this is how to build software, not how to build hardware. But the great thing about software is that, copying is free. Computers are basically infinite copying machines. So it's really easy to sort of be able to make multiple copies of something. Now, how you do that, you want to make sure that you build your software in a way so that it is modular enough to be redundant, right? So that you can add more pieces of whatever whatever module you need to, okay? Backups, if you're going to sort of think about being an actual product, you need to make sure that everything is backed up. Any piece of data is backed up anywhere, including your configuration files. And the main thing to remember about backups is that it doesn't count unless you've tried it out, right? And I'm totally guilty of this, right? Like I have like 20 automated backups running on all of our servers, and like 2 of them I've tried to make sure that I can actually restore from them, right? So the flip side of backup is restoration. If you're making backups and you've never tried to restore from them, it doesn't count as making backups because you don't know if you're missing something, right? You're like, oh, okay, my SQL database is being dumped every night automatically. That's great. Unless you've tried to restore it, when it breaks, and then you try to restore it, you may be up for a rude awakening, okay? So the key lesson about backups is it only counts if you actually try to restore from it at some point in time. Security audits, we talked about this. So you need to make sure that you're making smart decisions in your architectures to reduce security potential breaches. This is like if you use a database abstraction layer, then SQL injection is much likely to be a bug for you. If you need sort of the sort of low-hanging fruit are things like you never save passwords in clear text. You also sort of make sure that your password hash, where you encrypt it, is actually something that's not easy to guess. So basic things that turns out people forget this stuff all the time. Like we get a data breach like every 2 weeks where people's passwords are leaked. It's like, what? I can't believe that someone is still storing passwords in plain text. Huh?
Not here, you mean like...
Yes, sorry, not here, in general.
Oh, gosh.
Not me, but like I've gotten people, when I've been working in industry, I've gotten people that email me a spreadsheet of credit card numbers with names on it. And I'm like, what the, like, how is this okay? How did this get generated? How is it possible to generate this? And then how did you make the stupid decision to mail this to me, right? And now I can't delete it, right? Like once it's emailed, like it's, I can delete it from my mailbox, but like, it went out on email, so someone intercepted that in the middle. Too bad, all those credit cards are gone. This stuff happens because people forget simple things, So anything that you're saving, and luckily we have the assist of IRB at least. So at least here, if you're doing something, you have to get approval to make sure that you've thought about whether what you're doing is sensitive or not. You can still, after that, make stupid decisions, but at least you are forced to think about it. And as much as that's a pain in the rear, getting IRB approval often, like, it's important to remember how good it is that we're forced to think about that, because it's very easy to make really poor decisions. So think about those IRB proposals as when you get to them, if you haven't already, as an excuse to make sure that you're thinking about how sensitive your data is. And remember that, like, no data is anonymous, right? This sort of, the myth of anonymous data or anonymizing data is a myth, right? We've done great research in this building about how easy it is to take like 3 pieces of data about someone and figure out who they are. 3 pieces of metadata and figure out who they are. So security, as I talked about previously, security audits are the best thing when someone else does it. Like, someone else tries to break your system. You're very bad at figuring out where your security holes are because you wrote the software. Someone else is going to be much better at thinking about that. And then SSL everywhere, there's just no excuse for not using SSL at this point if you're sending data from one place to another. Sure, it's a little bit of a pain to generate the certs, but they don't cost much money. You can get them from MIT for free, but it takes a little longer. Or you can just order them. So we're talking like $30, and then you get some SSL certificates, and then we'll talk about a little later what the impact of that is, or how it works, but basically it means that people can't intercept your data in the middle. So someone can feel confident that, like, when you're using your credit card, that when you submit your credit card to an SSL website, then someone can look over your shoulder and read it, but once it's submitted in transit, no one can read it except the person that's getting it. So there's really very little excuse for not doing that at this point. It's just laziness, which again, I've been guilty of, but remember to do that. Okay, so handling load. So what does it mean to handle load? Well, there's lots of different definitions. I don't just want to talk about website hits, right? So on an interactive viz, like, if you want to think about scaling, if you're doing like some touchscreen thing or a wall thing, right? If there's 20 people standing in front of your thing instead of 1 flapping their arms and playing Flappy Bird or whatever it is, then you need to be able to handle those 20, right? And with interactive viz, it may be missing events, right? Like, if you're missing touches because there's too many touches and you're trying to process between them on the same thread, then you're going to be in trouble, and your app is going to do things that make it look stupid, right? It's going to be like, oh, this thing doesn't work. It's not responding. I'm going to touch faster to try to fix it, which makes the problem worse, right? It's almost always the case that, like, the thing that when something breaks because of scale, the user wants to do more of the thing that made it break, right? Like, if a website's not responding, what do? You reload, right? If it's not responding because the load is too high, reloading makes the load problem worse, thereby compounding your problem. So assume that when your thing breaks, it will be broken because people will keep on trying to do the thing that broke it. So with websites, this is the question, the handling load, how do you do it? Well, sorry, so with interactive viz, you want to make sure that, like, you try lots of people touching something or lots of people flapping, right? And that's fun to do because you get a lot of people to try your thing out, right? You want to do this before you start doing your research tests with real users, and you want to make sure that you handle it in an okay way, right? We call that failing gracefully, right? So it may be the case that you can't handle 20 people flapping their arms, but you want to fail gracefully. So what's a good way to fail gracefully? Maybe you try to figure out who the closest 2 are and just pay attention to them, at least something you can explain, right? Or just pop up a thing saying, hey, there's too many people, we need only 2. If you can catch that the problem is happening and let people know why that's happening, that's the best way to try to handle those with interactive stuff, I argue. With websites, it just shouldn't happen, right? Like, if your website's slow, that's because you haven't paid enough to have enough of them to make it fast, right? In this environment, we're generally pretty good at getting, the extra $40 a month or whatever to make it handle 10 times the amount of load, right? So with websites, it's really come down to a cost. Like, as long as you make good architecture decisions, it's just money, and I'm not talking thousands of dollars. I'm talking like on the order of like $30, $50 a month to make something handle 1,000 instead of 10. Right? So you get a lot for your buck. If you want to handle like 10,000, that's different. Then you need to pay even more. Databases, same thing. Just pay someone to replicate it so that you get multiple of them, or so that it's not a bottleneck, right? Mobile, the problem with scaling is multiple platforms. We talked about this, how Android's just brutal for supporting things. And I think, as I mentioned, there are services where you can upload your APK, like your application, and it deploys it to lots of phones. And then you can try it out on like a dashboard where you can see all the phones and which ones are crashing. But that takes tons of time. Cost isn't the problem there, time is the problem. So they say that that Android development takes 3 times as long as iOS development if you want to support like a large range of phones. I've heard that from multiple sources, and it's like I say maybe it's more on the line of 2, but I don't build mobile apps in an actual company, so I don't know like the order that's twice as much. But it's brutal to build products that are mobile. So be aware of that and budget for that if you want to support. Even if you're just supporting 10 people with their own devices, you want to try to filter for those 10 devices that you know are at least a certain version of Android, right? You can make decisions that limit the availability, right? You can say, like, oh, you have to use at least this version. And then suddenly it's way easier to test, and maybe it's only 1.5 times iOS or something. But then, of course, there's less people you can support. You know, it depends culturally. You know, in certain countries, there's a certain percentage that have this version of the OS. So you have to do that research beforehand. And humans. So if you're like building a website, a lot of people are going to be able to realize that your support scales, right? And I find that support doesn't scale linearly with the amount of people using it. It scales more sort of, not quite exponentially, but definitely much closer to exponentially, right? So if there's 100 people using it, and then there's 1,000 people using it, you get way more than 10 times the amount of support requests when 1,000 people are using it. I think it's about the sort of breakdown of the type of people that are using something. So be prepared to sort of handle that and know what you're going to do. Like if you're putting email, then you're going to get a barrage of emails, right? If you can very quickly get one of these support things where like it queues tickets up, and then you can handle them one by one, and you're not flooding your inbox, right? So you can very quickly put architectures into place that make support easier as well. So that's sort of the problem statement and a little bit of how you address it for scaling. Now I want to